All right, and welcome back, everybody. This is the next part of our scan of the engine block. As you can see, we haven't done any other work on this. This is just the straight scanned it. Took 5 minutes after setup and everything, and we ended up with this nice scan right here. We have our just one bit of scan data over in our tree on the left. You can see there's we don't have any noise data around in the air. Even some of these springs we're up on the heads are gone. It's because of our automatic D feature, remove isolated patches. So it cleans up my model for me right away. I don't have to do anything to actually clean it. Now what we want to do is try and reverse engineer this. And you might notice if we look around on this model, scroll around, you see we're missing some parts. We don't have the inside stuff down here. We don't have some underhangs on the engine over here. And you might think that's an issue, but it all depends what you want to do with your scan. So in this case, we're just going to be doing some reverse engineering of these upper surfaces where we want to grab the hole pattern data for these bolts. So to do that, we don't need a perfect complete scan. We don't have to spend an hour or two like scanning everything, getting perfect areas, all the little gaps and holes. We just need to get the data that we need to get, and then we can go and start doing something practical with it. So I'm going to show you how we can actually take this and get some reusable data to send over to Solidworks to actually start reverse engineering with. So we have our mesh data here. I'm going to go ahead and send it over to VX Model. So it makes a mesh data file for us. You see it just sent it over really easy like that. Now we actually have our mesh. So I'm going to hide our scan data so we just see our mesh data. Now we can go in and start grabbing features based off the triangle mesh data we have here. You'll notice we have a bunch of add entity options up here on the upper left. So with this, I'm going to go in and we're going to start with the grab plane feature, where we can actually go and start building constraining plane faces for where we can actually mount things. And then to make our life really easy, we have a bunch of filter selection tools over here. So default for selecting a plane, we have select triangles of similar normals. So all the triangles that have similar normals facing the same direction, it'll grab in one selection. And we can adjust the tolerance of that selection too. So all I have to do is click on this face here, and it's going to grab all the triangles with similar normals, give me a selection like that. We can even see the error distribution of our selection. And then I can go in and create that plane. And it creates a planar on the surface. And we can do that for all the relevant features we want on this part. So we'll grab one on the top area of this plane. We can refine our selection, grab more triangles, less triangles, grab more selection points, create that. I'm just going to grab a couple to start with here, just to show you guys how easy and quick it is to actually go about doing this. So you can see creating planes is just extremely easy. And for this down here, it's I want both of these faces, so I grab the other face, merges it all in the same plane, averages out. There we go. And we have a couple planes already created. Now what we want to do is grab the locations of all these bolt holes. So we'll go to a different feature here and we'll grab our circle feature. And what we're going to do is we're going to select a constraint plane to use on this. So for example, we'll just start with this one up top here, and we're going to grab some of these hole pattern data. And then what we're going to do is we're going to select the cylinder of the bolt, and then it's going to project that cylinder up onto that plane and give us our circle. And then from that circle, we'll be able to get an exact center point data that when we send it to SolidWorks, we could say, okay, at this center point, use the hole wizard, and then tell it, oh, hey, make this exact size hole right here. So I'm just going to go ahead and zoom in. Now all we have to do, based on our selection tool, we have a new filter tool defaulted to similar curvature when we're selecting stuff for a cylinder. So there's cylinder inside of here. So I'm going to click on that, and it's going to go ahead and select all the triangles with similar normals for that curve. So it's going to automatically grab the whole circle curve section for me. So once it's done thinking, it grabs a little selection like that. I can go in and I can refine this by grabbing more triangle data. Alright, and this is something that we can make easier by upping our tolerance up here. So I can grab bigger selection really easily, and it just projects that circle onto that plane. Hit create, and we'll just keep going, and we'll grab some more circle data from all the other sides. So you can see something like that, not the greatest. We're going to want to grab more circle data, so I just need to rotate around so I can see the other side of my circle. Where are we at? Here we go. Oh, so I selected the wrong data, so we just unselect and start over. Let's see where I got some better. Zoom in on that side. There we go. So now create that. And let's grab a couple more. Make sure I click on the right part. You don't want to click too far up onto your curves because that is where it's going to be getting to the fillets. There we go. Best fit that circle on. So we just have these 4 up here. Create that. And then we can also add constraint data on here. All right, so we have all 4 of those. And then we can see as I've been creating these features, they've just been building up into our entity tree over here on the left. So there's the planes I created and the circle patterns I created. If we want to go ahead and grab a couple more, so we'll just go constraint, let's go to this plane, zoom in down here, adjust my tolerance a little, grab the inside, create a circle, and just go through and really easily grab all this relevant data. See, these circles are a little bit bigger, so it's a lot easier for the scanner to get down into it to grab that data. And then once we have all this data, we'll be able to send it directly to Solidworks. And you can see we can, if we wanted to adjust any constraint data on here, so it's grabbing information for that circle and it's best fitting it. If I go to constraints, we could actually see what specific diameter it's recording it as, and if we wanted to, we could add design intent to our part. So I can say, okay, that might be 0.013 inch diameter bolt hole right there. I might actually say, okay, well, maybe they intended it for it to be 0.015 or something. I can just overwrite, type my own number in there, and it'll build that circle to that size. In this situation, it doesn't really matter because what we're going to be doing is bringing this into SolidWorks and just using the center point location for it. So we're going to grab the center of this hole, and let's grab some more data to make sure that fits better. You can see how the hole resizes. So when we bring it into SolidWorks, we're just going to grab the center point and apply, bolt hole wizard, and it'll have the exact size hole and callouts that we need for it. Okay, so now that we have these holes, and then for the rest of the part, we just keep going around doing the same thing. Selecting our plane, grabbing our cylinder data, having it project on the surface, and then we'll be able to transfer this directly to SolidWorks. If we want to do that right now, just real quick, to show you guys how easy it is, all we have to do is select it, then we go up here to transfer to SolidWorks, and it'll transfer it right on over into a SolidWorks part file. So it'll have planes and sketches and circles, and we'll end up with something like this. So those are those. Let's rotate this around. So here's the top plane up here. There's that side. Here's the bottom one. And the holes that are constrained on it, exactly where they need to be. So now in SolidWorks, we can just start drawing, extruding, cutting, and lofting, and build all our part directly up from here with our exact locations. And we might need a little bit more data from this, right? So I don't have the area where these bolts are on sticking out. So one of the great things about this is a iterative process too. You don't have to get all the information and send it over in one go and hope you got everything. So let's say I want to get this profile data around here. So let me go grab a cross section, grab a plane, and let's offset that down. Let's go a little more. Alright, so now I have an offset plane data right here. If I go ahead and hit create, it's going to create a lot of cross sections, but if we close that out, we can see what we have. So now I can transfer this data over into SolidWorks 2, and that'll come over as its own sketch plane that we can use to draw around the sides and actually get the actual area for our part to mount onto also. And let me do one more for the top piece up here. Plane 2. And again, we're going to offset it down, so we're not just getting the very top surface, we're getting the actual profile there. And let's go a little more. Create. So now if we grab this, same deal, I can go click transfer to SolidWorks, and it will transfer it directly on over to SolidWorks. And so there's a lot of little like holes and patches on there, but this comes across, and now we have this also as a sketch plane that we can start using to draw our circle. So we have, you know, a pretty good idea of the actual geometry that this thing's going to mount onto, the actual hole locations for it too that we can use to build to, and we're going to use all this as a pretty much a a design to help us build off of. So generally, you're not going to take the sketch data and extrude directly off of it, but we'll use it to draw our own lines around it, put our own fillets in, and do actual design geometry, design intent, get it how we want it to be. So then for the rest of the engine part, we just open up the rest of those parts, grab holes and planes for all the other features on here and send it on over. You see it's fairly quick and easy. I spend a whole 30 minutes on it. You probably have the whole engine done, ready to go in SolidWorks for all your hole patterns. I can actually open up another one I've done earlier with a bunch of hole pattern data. And you can see all the holes and bolt patterns that we want out of it directly in SolidWorks with planes that we can cut to. Next thing we'd have to do, if we want to, is grab all the those cross-section data to send over, and then we can have the actual planes that they'll be fitting on too for the amount of material it can hook against. But yeah, so if you need to do anything else on that, it's just really easy. We just keep sending data back and forth. And then from here, we'll build up our part, and then we'll see what we get for the rest of our process.